Okay, Algebra 1, lesson 29 is all about exponents. And part A, as you can see, is negative exponents. Before we get started with those, we're going to talk about place value. And so we're going to fill in this chart. Okay, so, thousands. I'm going to start out with exponents right away. Okay, so thousands. In the thousands place, you take whatever the digit is times 1,000 to get its value. 1,000 we're going to write using powers of 10 for all of these. 1,000 is 10 to the third power, so instead of 1,000 I'm writing that. Hundreds, okay, that's 10 squared. And then beside that we have the tens, which is 10 to the first. Okay, and you see this pattern, right? As we go one place to the right, the exponent's going down. 10 to the third, 10 to the second, 10 to the first. Well, 1 must be 10 to the 0. And then tenths, okay, that's 1 over 10 to the 1, right? And hundredths, that's 1 over 100, so that's 1 over 10 squared. And I'm writing this to the side for a reason. Thousandths, that's 1 over 1,000, but 1,000 is 10 to the third. Okay, but also following this pattern, 3, 2, 1, 0, negative 1, negative 2, whoops, got my negative in there too soon, negative 3, and it would keep going in either direction if we went further out with this. But this is enough to see the pattern. Okay, math involves many patterns. Okay, this happens to be one of those, and we can make use of this. We're told this is the definition, but it really makes sense based on this. Here our base was 10, and it's 3, 2, 1, 0, negative 1. This shows us two things that are coming up in this lesson. One is actually in part B, that 1 is equal to something to the 0 power. And the rest of this is about negative exponents, which is part A. And so I'm going to rewrite this. This part's not needed so much, but when we get to the negatives it is. Okay, so instead of tens, I'm using x for my base. That's more generic. Not what I wanted to do here either. Okay, 1 over x to the 1, and then x to the negative 1. 1 over x squared. You have to write a little bit small in these boxes. X to the negative 2. Okay, so this is demonstrating, again, both of the things from this lesson, and right now we're focusing on negative exponents. So here's our definition in the box. The definition of x to the negative n power, okay, is equivalent to 1 over x to the positive n. So if n is any real number, any number that can be graphed on the number line, and x is not 0, because we can't divide by 0, then this is true. Okay, and I have a little slogan or jingle or something that goes with this, and it's cross the line, but don't forget the line that doesn't rhyme. Cross the line being the fraction bar, to change the sign of the exponent. It only changes the exponent sign, not any other sign. People keep forgetting this part, but it you'll see. Okay, so that just helps us evaluate things, because look at example 1. Okay, in example 1, okay, exponents normally tell us how many times to multiply something by itself. How do I multiply something a negative number of times, right? So we use this definition, or that pattern that we saw, and we can rewrite this as 1 over 3 to the positive 2. Cross the line to change the sign of the exponent, only the exponent. It's not now somehow a negative 3. Okay? So now we can do 3 to the second. So 3 to the negative 2 is equivalent to 1/9. Okay, so here's one where we have a negative exponent in the denominator. So we're going to cross the line, the fraction bar. Oh, I forgot to add that up here. The line being the fraction bar. Okay, so we're going to bring this up, and that would, it doesn't mean the 1's not there anymore, it's just technically we have 1 times 3 to the positive 3rd power, because we brought this up. It does not change the sign of the base, it just changes the sign of the exponent. Okay, and 3 to the 3rd power is 27, and 1 times that is still 27, so it's 27. The original here was positive. The answer needs to be positive. Alrighty, one more here. Now we have a negative exponent. The base is also negative, but it's in parentheses. Okay, so we need to keep those parentheses as we're moving things. Moving it because we had a negative exponent. That needs to be removed before we can square. Okay, cross the line to change the sign of the exponent. That's still negative. The exponent is now positive. So now we're just squaring negative 3. This means negative 3 times negative 3 in the denominator. So that is 1/9. Okay, we're going to add one other one down here. We'll make that part A. Here's part B. Okay, so if we had same numbers, same base, same exponent, except, what's technically not the same base, no parentheses. This is the opposite of 3 to the negative 2nd power. So this means just keep the negative in front, okay? There we cross the line to change the sign of the exponent, and then that's negative 1/9. Okay, the parentheses make all the difference in that. Okay, now moving on, we're going to see some examples with a bunch of variables, and I think the book restates the product rule, but I didn't. You have that in your notes from before. I will mention it because we're going to use it here. When we simplify this, we find all the bases that are x's and add their exponents algebraically, and we find all of the bases that are m's and add theirs. So what we have here, there's a 4 and a negative 2. We're going to add those algebraically. We're subtracting because they're opposite signs. And then for m, we have a 2 and a negative 5. And so that's x to the 2nd, m to the negative 3rd power. All right, I should have checked your book. This is fine. It's fine to end it here. We also often make all the exponents positive for our final answer. So this would be acceptable, but also if I end up with a negative exponent, I just cross the line with that one and change it, the sign of the exponent. So x squared doesn't move. This would go. And I know you might be saying, what line? I should have addressed that on the other side. Anytime you have, not a fraction, you can put the thing over 1. So there. So when you cross the line, that line brings it to the denominator. Of course, you would never write your answer just over 1. unless you were asked for a ratio. Okay, so either of those would be a good answer for that. Here for this one, okay, we have x's, y's, and z's. For x, I have -2, 4, and then another 1. There's no number written there, but that's an understood 1. And then for y, we have -6 and 5. That's all. And then for z, I have a 1 and a 5. Again, if there's no exponent written, it's an understood 1. Alright, so for x, we have 5 minus 2 is 3. For y, we have -1, and z would be 6. And there is my answer, all simplified. Okay, so at the beginning of part A, I showed you that with the powers of 10 with place value, we saw that something to the 0 power is equal to 1, and they're stating here that that is a definition. It's just something to know. The pattern should help you remember that. Okay. Now, also consider this. Okay? This should just kind of reinforce it. X to the 4th, okay, times, and we know another way to write 1 over x to the positive 4th, right? I didn't want to write it that way here. I have that over there. Silly me. Got ahead of myself. We're going to do this normally. This is x to the 4th over x to the 4th. Something divided by itself, as long as something isn't 0, is equal to 1. Okay, that whole thing just simplifies to 1. The x to the 4ths cancel. But we also know that could be rewritten like it is over here. Okay, here's x to the 4th. This is equivalent to x to the -4. And if I use the product rule for exponents, I'm adding those. And that gives me x to the 0. Those two things that were printed here are equivalent. Therefore, these two things are equivalent. So you can either use the pattern from the chart in part A or this to help this definition make sense. But, I mean, definitions, just take them at face value also. It's just something to remember, but the pattern and this hopefully will help you to figure it out if you can't quite remember it. So we're going to simplify these things, still using the product rule. For x here, we have a 2 and a -2. And for y, we have 5 minus 2 is 3. You would never leave your answer like that. That's not completely simplified, because we know x to the 0 power is equivalent to 1. This is 1 times y to the 3rd, which is just y to the 3rd. Here, for m, we have a 5 and a 1. That's 6. And for b, we have a 2 and a -2. That gives us 0. 2 minus 2. Again, never leave it like that. Fully simplify it. B to the 0 is equal to 1. 1 times m to the 6th is just m to the 6th. Example 7 says to use the distributive property. The first thing I'm going to do is simplify what I see, because I see some 0 exponents. They're equivalent to 1. You know, that factor right there, that's equivalent to 1. So I can streamline this a little bit. I have x to the 5th times 1, which I don't have to write, times z. And then in the parentheses, p to the -3rd power times 1, which I don't have to write, minus 4 x to the -5, z to the -1. Okay, now I distribute. That means I'm taking this on the outside times both terms on the inside. And if I just keep them in the order in which I see them, x to the 5th, z, p to the -3 minus, except of course numerical coefficients go first, x to the 5 times x to the -5, that's x to the 0, z to the 1 times z to the -1, 1 minus 1, also 0. So my final answer is x to the 5th I could alphabetize them here. I think I will. P to the negative third, x to the fifth z, minus 4 times 1 times 1. But simplified, that's just 4. So that is the final answer to this one. Okay, expand also means distribute. Okay, see, used to expand, and then often the book just shortens it and just says expand. Okay, I don't see anything to simplify inside there, so we're just going to multiply. So we have x, negative 2, positive 2, that's a 0. Y, negative 2, positive 2, that's a 0. Plus 4. Okay, for x's we have a 4 and a negative 2. That gives us a positive 2. And y gives us a 0 again. Then we simplify this for our final answer. This is 1 times 1. That's 1. Plus 4x squared times 1, which we don't have to write. And there we are. Okay, just a few left here. Down here in example 9. Anything to the 0 power equals 1. Okay, there's a negative and then 1. Okay, negative 2 isn't to the 0 power here, it's just the 2. Exponents go to it's directly in front of them. There are no parentheses, so it's not negative 2, it's just the opposite of 2 to the 0. So it's the opposite of that one. Here in part C, this one is in parentheses, okay? 0 exponent goes to that whole number negative 2. So that whole thing is to the 0, so it's a 1. That hopefully that's something you can look back to while you're working to get these as you're working on learning these 0 exponents. Anyway, enjoy.